Today we're going to be talking about the relationship between physical activity and diabetes. This is Module 11. So first let's give an overview of diabetes. In the broadest sense, diabetes is simply abnormally high blood glucose or blood sugar. There are three types of diabetes that we're going to be talking about today: type 1, type 2, and gestational. And so we'll go through these. So first let's start with type 1 diabetes. Historically, this has been called either insulin-dependent diabetes mellitus or sometimes juvenile onset diabetes, sometimes just juvenile diabetes. However, this term is typically not used anymore because type 2 diabetes has become increasingly common in younger people, in juveniles, and so it's really a misnomer now. What happens with type 1 diabetes is that the cells of the pancreas, the beta cells, whose job is to secrete a hormone called insulin that breaks down or causes the body to take up and break down blood glucose, those cells are damaged because of an immune response. Basically, the body attacks its own pancreatic beta cells, and therefore insulin is not made in sufficient quantities, sometimes not at all. This form of diabetes typically occurs in childhood or adolescence, but onset in adults has been reported. It's less common, and about 5 to 10% of all cases of diabetes are type 1. It's really poorly understood what causes type 1 diabetes, but risk factors may be autoimmune or genetic factors. To some degree, type 1 diabetes runs in families, although it's certainly not guaranteed. And then there are some environmental factors that are thought to be related, but we really don't understand what causes diabetes. Type 2 diabetes is much more common, and therefore it's much more well understood. About 90 to 95% of all diagnosed cases are type 2, and this usually begins as what is called insulin resistance, which is when the cells of your body don't properly use insulin. Remember, insulin's job is to tell or signal your cells to take up blood glucose. So as you need more and more insulin, what happens is the pancreas eventually just says, I can't keep up, and therefore it quits producing insulin. At that point, you would not be insulin resistant anymore, you would have full-blown diabetes. So type 2 diabetes is associated with older age, obesity, family history of both type 2 diabetes and gestational diabetes, impaired glucose metabolism, physical inactivity, and there's a much higher prevalence of type 2 diabetes in particular races. In particular, African Americans, Hispanic or Latino Americans, American Indians, and some Asian Americans have a particularly high risk for type 2 diabetes. There's a Native American tribe that is primarily located in the southwestern United States, the Pima Indians, where the prevalence of type 2 diabetes in that population is somewhere between 60 and 70%. And this has to do, I believe, my understanding is, with both genetic and lifestyle factors. And as I mentioned on the previous slide, type 2 diabetes is becoming more frequently diagnosed in children and adolescents, which is why the terms type 1 and type 2 are now used as opposed to juvenile and adult diabetes. So let's talk a little bit, let's give a real simple version of how this occurs. Okay, so in the purple is a cell. Think of it as a muscle cell. And then outside of the cell, the little blue hexagons are glucose, sugar, and then the purple triangles is insulin. So when you consume food, it has some level of glucose in it. Some foods have a lot of sugar, some have a little, but there's always some glucose. Your body needs glucose to fuel it. In particular, your brain requires glucose. The brain is the one organ that cannot break down any other types of fuels, not fats, not proteins. It must have glucose. So glucose needs to get into the cell to be broken down. So on the surface of the cell, you see in yellow, that's a GLUT4 transporter, and then in red, there's a glucose transporter. And these come to the cell surface, and they basically provide a pathway for glucose to enter the cell. But the signal that tells the cell you should let glucose in is called insulin. It's a hormone. And so the insulin binds to these green receptors on the cell's surface, and that in turn tells the transporters to allow glucose in. So in type 1 diabetes, basically your pancreas is damaged and it doesn't make enough insulin. So there's simply just not enough insulin to signal the insulin receptors to take up blood glucose. So it happens a little bit. You get a little bit of glucose transport into the body, into the cells, but not enough. And so what happens is that the glucose can't get into the cell. It's stuck in your bloodstream, and therefore when you measure the amount of glucose in the blood, that value appears to be high because glucose stays in the blood. It can't get into the cells. With type 2 diabetes, there's plenty of insulin. The only difference really is that your insulin receptors stop working. They become resistant to insulin, and so they don't properly signal the GLUT4 transporters to take up the glucose. So really the effect is the same. Glucose can't get into the cell, therefore the levels of glucose in the bloodstream remain high. And here is another diagram to try to demonstrate the role of insulin. So in the middle of this diagram you see what's called homeostasis in terms of blood glucose. You want to maintain a constant blood glucose level. Like I mentioned before, the brain must have blood glucose to function. So if you consume a meal, your blood glucose level goes up. Now we're going to go into the upper portion of this diagram. So let's go to the upper left. So if your blood glucose rises, the beta cells of the pancreas release insulin. Remember, the job of insulin is to signal the cells of the body, not just the muscle cells, but that's one of the main targets. So it signals the muscle cells to take up the glucose, and you can use it as an energy source. What's left over that you don't need, or you're not burning off, is converted by the liver to glycogen, which is a stored sugar, basically, and it can also be converted to fats and proteins. So either the liver or the muscle takes up the glucose, and that causes your blood glucose level to fall back to normal. On the opposite end of this spectrum, say you don't eat for a while, your blood glucose level goes down. Remember, your body wants to maintain homeostasis, or a constant level of blood glucose. So if your blood glucose level is dropping, the pancreas releases a different hormone called glucagon. And glucagon signals the liver to release glycogen, which is a stored form of glucose. So glycogen gets converted to glucose, and that's released into the bloodstream, and that causes your blood glucose level to go back up, again, to maintain homeostasis. All right, the third type of diabetes to mention is called gestational diabetes. And this is a form of diabetes that's diagnosed during pregnancy. It occurs more frequently among African Americans, Hispanic and Latino Americans, and American Indians, so in the same racial and ethnic groups that we see an increased prevalence of type 2 diabetes. It's also more common among women who are obese or who have a family history of type 2 diabetes. So typically this requires treatment to normalize blood glucose levels because there can be problems in the baby, particularly the baby gets too large and then delivery is very difficult. Other problems can be hypoglycemia, low blood sugar right after the baby is born. Essentially, the baby's been supplied with a high level of sugar for a long period of time in utero, and then when they're born and the cord is cut, they literally have been cut off from their supply of glucose, and so they can develop complications from that. So in women who have gestational diabetes, about 5 to 10% of those end up developing type 2 diabetes. However, for most women, gestational diabetes goes away after delivery. However, women who have had gestational diabetes have somewhere between a 20 and 50% chance of getting diabetes type 2 in the next 5 to 10 years. So it typically is a warning sign, and lifestyle change can be at preventing that. So how is diabetes diagnosed? This is true for both type 1 and type 2. There's a couple different types of testing, but let's just focus on the oral glucose tolerance test. Basically what you do is you drink a solution that has a high level of glucose or sugar in it, and then after a certain period of time, a blood sample is taken and the amount of sugar in the blood is measured. So someone with normal blood glucose would have a level of glucose less than 140 milligrams per deciliter, and then impaired would be between 140 and 199, and then someone with diabetes, and this would be diagnosed after an oral glucose tolerance test value of greater than 200 milligrams per deciliter. So basically, more blood glucose left in the blood after a certain period of time means your body's not able to clear it, and that suggests that the pancreas isn't working properly. Here's the prevalence of diabetes in a variety of countries around the world, and on the very far right you can see the United States and Mexico. This should be a pretty alarming statistic to you. About 10% of American adults ages 20 to 79 have diabetes. In youth, the prevalence is increasing. So on the left-hand side of the x-axis, you see youth under age 10, and so you're looking at all non-Hispanic white, African American, Hispanic, American Pacific Islander, and American Indian. Those are the different groups that are labeled on the axis. And type 1 is indicated with a gray bar, and the black bars are type 2 diabetes. So you can see that type 2 diabetes is very rare in children under age 10 in all groups. But in 10 to 19-year-olds, you see an increase in the prevalence considerably, especially in type 2 diabetes. The biggest prevalence in adolescents is in American Indians. So next, let's talk about, can exercise or physical activity have an impact on diabetes? So let's particularly focus on type 1 first. Unfortunately, there's no evidence that exercise can treat type 1 diabetes. However, patients, of course, still get many benefits from physical activity, like reduced risk of cardiovascular disease, reduced risk of mortality, etc. For type 1 diabetes, the only potential problem is when you exercise, this increases your metabolic rate, and it increases the rate at which glucose is utilized. So if someone is, usually type 1 diabetics take insulin artificially, they give themselves injections, and so if you're going to be exercising, it may be necessary to reduce the amount of insulin that is taken. Otherwise, if you have your normal amount of insulin and you're exercising, you might end up with hypo or low glycemia, low blood sugar. So type 1 diabetics have to be careful about exercise, and they just have to plan cautiously. With type 2 diabetes, there is considerable evidence that shows that exercise is an effective treatment and prevention, which is really good news. So let me show you how this works. You've seen this diagram before. With type 2 diabetes, remember there's insulin resistance. There's plenty of insulin, it just doesn't work properly. It doesn't signal the GLUT4 receptors to bring insulin to bring glucose into the cell. So what happens with diabetes and exercise, type 2 diabetes, is that essentially exercise allows the insulin receptors to be bypassed. Exercise signals GLUT4 transporters, additional GLUT4 transporters, to move to the surface of the cell, and if there are more transporters, they can bring in glucose into the cell. So exercise bypasses the insulin receptors and allows glucose to be taken up. They're very effective at increasing the ability of the cells to take up glucose. So this figure shows the relationship between physical activity and leisure time, so not work, but leisure or recreational activity. And you see a very strong dose-response relationship between physical activity and relative risk for type 2 diabetes. So the more physical activity, the lower risk. Intensity is also related. So you're looking at data from the nurses' health study and the physicians' health study. One study obviously looked at all nurses, another study, both are cohorts, but another was a cohort of physicians. And so in nurses and physicians who were exercising more than once a week, there was a significant reduction in risk for type 2 diabetes, and after adjusted for BMI, which is a potential confounder, you still see a decreased risk. And then if you look at fitness, physical fitness, not just activity, but fitness, you're looking at relative risk of type 2 diabetes on the y-axis. So what you see, the first 3 bars from the left-hand side are people who are fit, and the 3 bars on the right are people who are unfit. Same trend as we've seen with other health outcomes. Being physically fit protects against type 2 diabetes. Yes, it's better to be normal weight, but it's also considerably better to be physically fit. So the worst group to be in is unfit and obese. Next, let's talk about prevention. Say you have a family history of type 2 diabetes, but you don't have it yet. Can you prevent getting type 2 diabetes? This study was called the Diabetes Prevention Program. It was a large randomized controlled trial where people with a family history of diabetes, type 2 diabetes, were enrolled in one of 3 groups, either a placebo group where they took a pill each day that they were told was a drug, or they took the actual drug, which is called metformin, or they were enrolled in a lifestyle intervention where they were physically active. And you can see the incidence of diabetes on the y-axis. The x-axis is over time. 4 years was how long the intervention went on. So the placebo group, about 35% of people in the placebo group developed type 2 diabetes in 4 years, whereas only about 25% of the metformin group and only about 20% of the lifestyle group. This is data from the same study. On the x-axis, you see the years of follow-up, year 1, 2, 3, and 4. And you're looking at fasting glucose levels. So you want the fasting glucose levels to be lower. And there was not a lot of difference. I know these look a little bit different, but statistically there weren't differences in fasting glucose, except that from year 1 to 2 to 3 to 4, glucose levels went down in everyone. Here's probably the strongest data showing that diabetes can be prevented by exercise and diet. So the placebo group is your reference group. The metformin group had about a 30% reduced risk, because the relative risk, if you look at the diagram, looks to be about 0.7. And then the exercise and diet group the relative risk is about 0.4, so a 60% reduced risk, which is a very powerful prevention. So in summary, the diabetes prevention program did reduce the incidence of type 2 diabetes by 11% in the placebo group, so something about taking a pill actually reduced incidence even though the pill was a placebo. You had a 31% reduction in the metformin group and a 58% reduction in the lifestyle group. So again, exercise and diet is a very powerful tool for reducing incidence of diabetes. Here's one more study I want to talk about. Typically, we think of aerobic exercise as helping with diabetes, but there's been some interesting research lately about resistance training. In this study, they used a cohort design, and they studied men, more than 32,000 men, who did either resistance training, aerobic training, or both. They followed them over time and assessed their risk of developing type 2 diabetes. So here's the data. Let me walk you through this. On your x-axis, there's people who either did not adhere to recommendations for aerobic exercise, meaning they did not meet physical activity recommendations of 150 minutes per week, or yes, they did. And then the different markers, the black circle, the white box, the white circle, and the black box, those are how much resistance training they did per week. So the black circle is none. The white square is between 1 and 59 minutes a week. The white circle is 60 to 149 minutes per week, or the black square is more than 150 minutes per week of resistance training. And then anything below this line at 1.0 was a reduced risk of diabetes. So let's start with those who did not adhere to aerobic exercise recommendations. So in people who did not get enough aerobic physical activity, even in that situation, somebody who gets 150 minutes per week of resistance training only, they cut their risk by more than half of developing type 2 diabetes. And even if they do less than an hour a week, they still considerably reduce their risk. If you look at those who, yes, do meet recommendations for aerobic exercise, you see that even if they do no resistance training, they have a reduced risk. But I want you to really notice that the two black squares are actually at very similar risk. So what this shows is essentially that resistance training, what we typically think of as lifting weights, is actually just as effective at reducing risk of diabetes as is aerobic exercise. It's great to do aerobic and resistance training, but in terms of diabetes, you don't actually get any additional benefit. So if you like to lift weights, lift weights. If you like to run, run. Whatever it is, either or both of those will reduce risk of diabetes considerably. So today, you have discussion 4, and tomorrow will be the last module.